Hey there, science fans! It's your old pal, Bill Nye, here to talk about something truly electrifying. And no, I don't mean a rock concert. Today we're diving into the world of potatoes. Yes, you heard that right, potatoes. Now you might be thinking, Bill, what's so electrifying about potatoes? They're just, well, potatoes. And you wouldn't be entirely wrong. They're delicious mashed, baked, or fried. But what if I told you that these humble spuds hold a secret, a shocking secret? Believe it or not, potatoes can generate electricity. That's right, we're talking about potato power. It might sound like something out of a science fiction movie, but I assure you, it's very real. And the science behind it is truly fascinating. So, how can a simple potato, something you find in your pantry, transform into a source of electricity? Well, the answer lies in the potato's chemical makeup. You see, potatoes contain electrolytes, which are substances that can conduct electricity when dissolved in water. These electrolytes act like tiny bridges, allowing electrons to flow and create an electrical current. Think of it like a river carrying tiny boats, electrons, across its stream. The river is our electrolyte solution, and the boats are the electricity. Now, you might be wondering, but Bill, how do we get the electricity out of the potato? That's where things get even more interesting. We need to create a circuit, a closed loop that allows the electricity to flow. And to do that, we'll use two different metals, called electrodes. One electrode will act as the positive terminal, and the other as the negative terminal, just like a regular battery. By inserting these electrodes into our potato, we're essentially creating a miniature power plant. The chemical reactions happening inside the potato will cause electrons to flow from one electrode to the other, generating a small amount of electricity. It's like magic, but it's really science in action. And the best part is, this experiment isn't just about lighting up a light bulb. It's about understanding the fundamental principles of electricity and how it can be generated from the most unexpected sources. This experiment is a fantastic way to explore the world of science and learn about concepts like electrolytes, electrodes, circuits, and electrical currents. It's hands-on, it's engaging, and it's a whole lot of fun. Get ready to light things up. So, are you ready to unleash your inner scientist and create your very own potato battery? In this experiment, we'll show you step by step how to turn a simple spud into a source of electrical power. We'll go over all the materials you'll need, guide you through the process, and explain the science behind every step. By the end of this experiment, you'll be amazed by what you can achieve with just a few simple materials and a little bit of scientific curiosity. Get ready for an electrifying adventure because we're about to turn up the voltage with the power of potatoes. Stay tuned. All right, science explorers. Before we dive into the electrifying world of potato power, we need the star of our show, the mighty potato. Any type will do, whether it's a russet, Yukon Gold, or even a sweet potato. Remember, the bigger the potato, the more power we can generate. Next up, we need some copper wire. Copper is an excellent conductor of electricity. Think of it like a superhighway for our tiny electrical charges. Now, let's talk about our electrodes. Remember, electrodes are the metals that we insert into the potato to create a circuit and get the electricity flowing. For this experiment, we'll be using two different types of metal, zinc and copper. Zinc is a reactive metal, which means it has a tendency to lose electrons. We'll be using galvanized nails as our zinc electrodes. These nails are coated with a layer of zinc, which is perfect for our experiment. On the other hand, copper is less reactive than zinc, meaning it's less likely to lose electrons. We've already got our copper wire, and we can fashion it into our copper electrode. Why two different metals? Well, that's the key to creating an electrical potential difference, also known as voltage. This difference in reactivity between zinc and copper is what drives the flow of electrons and generates electricity in our potato battery. We're almost there. To complete our potato power setup, we'll need a few more things. First, we need more copper wire to connect our electrodes and create a closed loop for the electricity to flow through. We also need something called an LED, or light-emitting diode. This is a special type of light bulb that lights up when electricity flows through it in one direction. LEDs are very energy efficient, which is perfect for our low-power potato battery. Finally, to make sure our connections are secure, we'll use alligator clips. These handy clips have teeth that can clamp onto wires and electrodes, ensuring a good electrical contact. And there you have it. With these simple materials assembled, we're ready to unlock the hidden power of the potato and bring our experiment to life. Get ready for some electrifying fun. All right, science sleuths, let's get down to business. Our first mission is to prepare our potato for its starring role as a power source. Remember that ordinary-looking spud in your kitchen? We're about to give it an electrifying makeover. Start by giving your potato a good rinse under running water. We want a clean surface for our electrodes to make good contact. Think of it like washing your hands before a delicious meal. It's all about good hygiene for optimum results. You can pat it dry with a towel, but don't worry about peeling it. The skin won't affect our experiment, and we want to keep things as simple as possible. Remember, science should be accessible to everyone, even those who haven't mastered the art of potato peeling. Now take a moment to appreciate the simplicity of our main component. It's just a humble potato, yet it holds the potential to generate electricity. Isn't science amazing? With our potato prepped and ready, it's time to introduce our first electrode, the zinc-coated nail. Remember, zinc is more reactive than copper, meaning it readily gives up electrons, making it our negative terminal. Carefully push the galvanized nail into the potato. You want it to go in deep enough to make good contact, but not all the way through. Think of it like giving the potato a firm handshake, not a bone-crushing squeeze. As you insert the nail, imagine those tiny zinc atoms eager to release their electrons and embark on an electrifying journey. It's a microscopic world of energy just waiting to be unleashed. Now, set the potato aside for a moment and let's turn our attention to creating the positive terminal with our copper wire. For our positive terminal, we'll be using a coil made from our copper wire. Why a coil? Well, the coiled shape increases the surface area of the copper in contact with the potato, enhancing the flow of electricity. Take a length of copper wire and wrap it neatly around a pen, a marker, or even your finger a few times to create a coil. Aim for about 3 to 4 loops to maximize the contact area. Once you've created your copper coil, gently push it into the potato, making sure it's a good distance away from the zinc nail. Remember, we want to create a clear path for the electrons to flow between our two electrodes. Think of the potato as a racetrack and the electrons as tiny race cars. We've set up our starting line, zinc nail, and our finish line, copper coil. Now let's connect them with a conductive pathway. Section 4. Wiring the circuit. Connecting the dots of energy. Now comes the exciting part. Connecting our electrodes and completing the circuit. This is where the magic truly happens, where we bridge the gap between our zinc and copper terminals and allow the electrons to flow freely. Take an alligator clip and connect it to the exposed end of the zinc nail. Then, take another alligator clip and connect it to one end of your LED light. Make sure you connect the longer leg of the LED which is the positive side, to the copper wire. Now for the final connection, attach another alligator clip to the shorter leg of the LED, negative side, and clip it to the free end of the copper coil sticking out of the potato. With this final connection, we've completed our circuit. We've created a closed loop for the electrons to travel from the zinc nail, through the potato, to the copper wire, through the LED, and back again. It's like a miniature electrical highway. Section 5. The moment of truth. Lighting up with potato power. Drum roll, please. It's showtime. If everything is connected properly, you should see your LED light up. That's right. We've harnessed the power of the potato to generate electricity and illuminate our LED. Take a moment to appreciate the wonder of what you've just achieved. You've taken a simple potato, a few pieces of metal, and a tiny light bulb, and demonstrated the fundamental principles of electricity. Remember, the LED is very sensitive to the direction of current flow. If it doesn't light up immediately, try reversing the connections on the LED legs. Sometimes, a little troubleshooting is all it takes to get things working. Now, let's take our experiment a step further and measure just how much electricity our potato battery is generating. Section 6. Testing 1, 2, 3. Measuring the voltage. While seeing the LED light up is proof enough that our potato battery is working, wouldn't it be cool to actually measure the voltage it's producing? With a simple tool called a multimeter, we can do just that. A multimeter is a handy device that can measure various electrical properties, including voltage, current, and resistance. For this measurement, we'll set our multimeter to the voltage setting, indicated by the letter Vi. Now, touch the black probe of the multimeter to the negative terminal of our battery, the zinc nail, and the red probe to the positive terminal, the copper wire. The multimeter will display the voltage being generated by our potato battery. You'll likely see a voltage reading of around 0.5 to 1 volt. While that might not seem like much, it's enough to power our LED. Remember, it's not about the amount of power, but the principle of generating electricity from an unexpected source. Ready to take our potato power to the next level? By connecting multiple potato batteries in series, we can increase the voltage and potentially power even brighter LEDs or other small devices. Connecting batteries in series means connecting the positive terminal of one battery to the negative terminal of the next battery, creating a chain. This arrangement allows the voltage to add up, providing more power to our circuit. So, grab a few more potatoes, repeat the steps we've covered, and connect them in series. You'll notice that the LED glows brighter as you add more potatoes to your chain, demonstrating the cumulative effect of connecting batteries in series. This concept of connecting batteries in series is the same principle used in everyday batteries, like the ones you find in your remote control or flashlight. It's a fantastic way to illustrate how we can scale up power output by combining multiple energy sources. Congratulations, science adventurers! You've successfully built your own potato battery, measured its voltage, and even learned how to increase its power output by connecting multiple potatoes in series. But the fun doesn't stop there. Now that you understand the basics, it's time to unleash your creativity and explore the endless possibilities of potato power. Try using different types of potatoes, fruits, or even other vegetables to see which ones generate the most electricity. You can also experiment with different types of electrodes, like pennies or aluminum foil, to observe how they affect the voltage output. Remember, the key to scientific discovery is curiosity, experimentation, and a healthy dose of fun. So, go forth, explore, and see what amazing things you can power with the humble potato. All right, science enthusiasts, let's delve into the fascinating world of potato power. We've seen the magic of the potato battery, but now let's understand the science behind it. Electrolytes are the unsung heroes, acting as tiny electrical bridges within our potato battery. They enable the flow of electrons between our zinc and copper electrodes. Now, let's turn our attention to our dynamic duo of electrodes, zinc and copper. These two metals, chosen for their differing reactivity, are key in our electrochemical reaction. The acidic environment causes zinc atoms to lose electrons in a process called oxidation. These electrons begin their journey through our circuit. The electrolyte solution provides a conductive pathway. This difference in reactivity creates voltage, driving the flow of electrons and generating electricity. The interaction between the zinc and copper electrodes, facilitated by the electrolyte solution, involves two crucial processes: oxidation and reduction. These two processes always occur together, like two sides of the same coin, and are essential for the flow of electricity. Oxidation is the process of losing electrons. In our potato battery, oxidation occurs at the zinc electrode. The zinc atoms lose electrons, becoming positively charged zinc ions, which then dissolve into the electrolyte solution. Reduction, on the other hand, is the process of gaining electrons. This process takes place at the copper electrode. Electrons traveling through the circuit from the zinc electrode are attracted to the copper electrode, where they combine with hydrogen ions, H+, present in the electrolyte solution. This reaction forms hydrogen gas, H2, which might appear as tiny bubbles near the copper electrode. The continuous cycle of oxidation at the zinc electrode and reduction at the copper electrode, connected by the flow of electrons through the circuit, is what keeps the electrical current flowing and our LED glowing. While electrons carry electrical current through the wire and LED, ion flow within the potato is crucial. Remember those electrolyte taxis? Zinc ions create a positive charge near the zinc electrode, while hydrogen ions create a negative charge near the copper electrode. Potassium ions move towards the copper electrode, and chloride ions move towards the zinc electrode, completing the circuit. Section 5. Potato power in action. A simple circuit with big potential. So there you have it. Lighting an LED with a potato is a fascinating interplay of chemical reactions, electron flow, and ion transport. Our potato battery exemplifies the fundamental principles of electrochemistry. The flow of electrons from zinc to copper, powered by the potato, illustrates an electrochemical cell. Anode, or zinc, is where oxidation occurs. Cathode, or copper, is where reduction occurs. The potato provides a conductive pathway for ion flow. Section 6. Beyond the spud. Exploring other sources of natural energy. While the potato battery is a fantastic illustration of electrochemical principles, the wonders of science don't stop there. The same principles that allow us to generate electricity from a potato can be applied to a variety of other fruits, vegetables, and even liquids. Try experimenting with lemons, limes, oranges, or even pickles. Their acidic nature makes them excellent electrolytes, capable of facilitating the flow of electrons between electrodes. You can even try using salt water or sports drinks as your electrolyte solution. Remember, the key is to choose materials with differing reactivity for your electrodes. The greater the difference in reactivity, the larger the electrical potential difference, and the more power your battery can generate. Exploring these alternative sources of natural energy not only reinforces the scientific principles we've learned, but also sparks creativity and encourages a deeper appreciation for the hidden potential within the natural world around us. Section 7. From potatoes to power plants, the science of scaling up. While our potato battery might not be powering our homes anytime soon, the principles it demonstrates are scalable and form the foundation for larger, more powerful batteries that power our modern world. From the tiny button batteries in our watches to the massive lithium-ion batteries powering electric vehicles, the underlying science remains the same. Harnessing the movement of electrons through electrochemical reactions to generate electricity. Of course, the complexity and sophistication of these batteries far exceed that of our humble potato battery. Scientists and engineers have dedicated countless hours to developing advanced materials, optimizing designs, and improving efficiency to meet the ever-growing energy demands of our society. Yet, at their core, these technological marvels still rely on the fundamental principles of electrochemistry that we've explored through our simple yet elegant potato battery experiment. Section 8. Keep experimenting. The journey of scientific discovery continues. Congratulations, fellow science explorers! You've journeyed into the fascinating world of electrochemistry, uncovered the secrets of the potato battery, and even glimpsed the vast potential of natural energy sources. But the journey doesn't end here. The true beauty of science lies in its endless capacity for exploration, discovery, and innovation. So keep experimenting, keep questioning, and keep pushing the boundaries of your scientific curiosity. Try building potato batteries with different electrode materials, connecting multiple batteries in series or parallel, or even designing your own unique experiments to investigate the factors that affect battery performance. Remember, every experiment, no matter how simple or complex, is a step forward on the path of scientific discovery. And who knows, maybe one day, your curiosity and ingenuity will lead to groundbreaking innovations that will power our world in ways we can only imagine. Spud Science. Answering your burning questions. We've journeyed through the electrifying world of potato power, but the quest for knowledge never ends. Now it's time to tackle those burning questions. Get ready for a rapid-fire round of Spud Science Q&A. Can I power my house with potatoes? Not exactly. The power it produces is quite small. You'd need an enormous field of potatoes to power a single light bulb. Why use zinc and copper? Their difference in reactivity. Zinc loses electrons, copper accepts them, creating electrical potential. Can a potato power my house? Unraveling the mysteries of potato power. What makes the LED light up? The LED lights up when electricity flows through it. Electrons flow from zinc to copper, powering the LED. It's converting chemical energy into electrical energy. Why does the LED only light up with both electrodes? Electricity needs a closed loop to flow. Connecting both electrodes creates this loop, lighting the LED. Section 3. Beyond the battery. Exploring other electrifying experiments. Now let's venture beyond the potato patch and explore other electrifying avenues of scientific exploration. A question that often pops up. Can I use other fruits or vegetables besides potatoes? Absolutely. Many fruits and vegetables contain electrolytes and can be used to make batteries. Try lemons, limes, oranges, or even pickles. Their acidic nature makes them excellent conductors. Experiment with different combinations and see which ones generate the most power. And here's a question for the truly adventurous. What other fun science experiments can I try at home? Oh, the possibilities are endless. You could explore the world of magnetism with a homemade compass, delve into the principles of buoyancy by building a miniature boat, or even investigate the power of air pressure with a simple balloon rocket. Remember, Science is everywhere, and the best way to learn is by doing. So, gather your materials, put on your thinking caps, and get ready for an adventure of scientific discovery. Section 4. Keep the current flowing, encouraging lifelong scientific exploration. As we wrap up our electrifying exploration of potato power, remember that this is just the beginning of your scientific journey. Never stop questioning, experimenting, and exploring the world around you with a curious mind. Science is more than just textbooks and labs. It's a way of thinking, a process of discovery that fuels innovation and solves problems. Embrace the power of observation. Ask why and how, and don't be afraid to make mistakes along the way. Remember, every great scientist started with a single question, a spark of curiosity that ignited a passion for understanding the world around them. So, keep that current of curiosity flowing. And who knows what amazing discoveries you'll make. Keep those science brains buzzing and stay curious, my friends. Well, science fans, we've reached the end of our electrifying adventure into the world of potato power. We started with a simple spud, a few pieces of metal, and a healthy dose of curiosity. And we ended up generating our own electricity and illuminating an LED. Along the way, we learned about electrolytes, those tiny electrical bridges that facilitate the flow of electrons within our potato battery. We explored the differing reactivity of zinc and copper, creating an electrical potential difference that drove the current through our circuit. We witnessed the magic of oxidation and reduction, those fundamental chemical processes that govern the flow of electrons and power our electrochemical cell. And we marveled at the crucial role of ion flow, ensuring charge balance and maintaining the continuous flow of energy. But more importantly, we rekindled that spark of curiosity, that innate desire to understand how things work that drives scientific exploration and fuels innovation. Our journey into the world of potato power has shown us that science is everywhere, waiting to be discovered in the most unexpected places. It's in the food we eat, the devices we use, the natural phenomena we observe every day. The principles we've explored extend far beyond our humble potato battery. They form the foundation for the batteries that power our smartphones, laptops, electric cars, and countless other technologies that shape our modern world. But the realm of science extends far beyond batteries. It encompasses the vast expanse of the cosmos, the intricate workings of the human body, the complex interactions within ecosystems, and so much more. Remember, our potato battery experiment was just a taste, a tantalizing glimpse into the vast and wondrous world of scientific exploration that awaits those who dare to question, experiment, and seek answers. As we bid farewell to our potato-powered adventure, I encourage you to carry that spirit of curiosity with you wherever you go. Never stop asking questions, challenging assumptions, and seeking new knowledge. The world is full of mysteries waiting to be unraveled, problems waiting to be solved, and innovations waiting to be discovered. And you, with your inquisitive mind and thirst for knowledge, have the potential to make a difference. So, keep experimenting, keep exploring, and never lose that sense of wonder that makes science so captivating. Try building your own variations of the potato battery, explore other sources of natural energy, or dive into a completely different scientific pursuit that piques your interest. Remember, the journey of scientific discovery is not about memorizing facts or achieving perfect results. It's about embracing the unknown, embracing the process of inquiry, and finding joy in the pursuit of understanding our amazing universe. Remember, science isn't just for scientists and engineers, it's for everyone. It's a way of thinking, a way of interacting with the world around us, a way of asking questions and seeking answers. And the best part is, you don't need a fancy lab or expensive equipment to engage in scientific exploration. So keep those science brains buzzing, my friends. Stay curious, stay engaged, and never stop exploring the wonders of the natural world. And who knows, maybe one day, your scientific curiosity will lead to a groundbreaking discovery that changes the world as we know it. Until next time, stay curious.